To maintain a consistent 60 frames per second rate, every frame must render in under 16.67 milliseconds. When displaying 10,000 items, the primary performance bottleneck is not data retrieval speed. The critical constraint is the cumulative cost of view inflation, layout calculation, and data binding. Excessive inflation of complex view hierarchies directly causes frame drops, which developers call jank. Our immediate goal is minimizing the time spent within the measure and layout phases of the rendering pipeline. We must ensure views are reused effectively across the entire list. The data binding process must execute instantaneously, never exceeding a few milliseconds. Initializing complex views or performing heavy setup outside the critical rendering path is mandatory for achieving smooth scrolling performance. If the view hierarchy is too deep, the layout pass alone will consume the entire 16.67 millisecond budget, guaranteeing jank. RecyclerView relies on the recycled ViewPool mechanism to store and reuse view holders based on their specific view type identifier. Performance degradation occurs immediately when this pool is exhausted, forcing the system to execute expensive view inflation operations. Developers must manually increase the pool size for frequently used view types to minimize inflation cost. Configure this optimization using the setRecycledViewPool method followed by setMaxRecycledViews, specifying the view type integer and the desired maximum count. If your application utilizes multiple recycler views displaying identical item layouts, they must share the same RecycledViewPool instance. Sharing the pool maximizes reuse efficiency across different screens, preventing redundant inflation. Avoid using a single view type identifier for vastly different visual layouts. Distinct view types enable precise pooling and guarantee faster retrieval of the correct view holder structure, optimizing the binding preparation time. UITableView and UICollectionView manage cell reuse through dedicated queues identified by a unique reuse identifier string. Failing to register the cell class or the corresponding nib file before attempting to dequeue results in immediate runtime errors or significant performance penalties. The system might fall back to manual instantiation if registration is skipped. Always use the dequeue reusable cell with identifier for method to guarantee a valid, recycled cell instance is returned, ensuring the reuse mechanism is active. When implementing heterogeneous lists containing various cell designs, ensure every distinct cell structure utilizes a unique, constant reuse identifier string. If a cell requires substantial configuration changes based on the underlying data, consider implementing multiple specific cell types instead. This approach simplifies the binding process and eliminates complex conditional logic within a single cell class, improving readability and execution speed. Deep view hierarchies exponentially increase the processing time required for the measure and layout passes on both Android and iOS platforms. Developers should aim for a maximum depth of 3 to 4 nested views within the list item layout structure. On Android, utilize ConstraintLayout to achieve complex positioning in a flat structure, or employ the merge tag to eliminate unnecessary root containers when including layouts. Avoid traditional nested linear layouts entirely, as they trigger multiple layout passes. On iOS, leverage UI stack view for simple linear arrangements, but exercise caution regarding its performance cost in complex, deeply nested scenarios. In high-performance lists, manual constraints often prove faster than relying on deeply nested stack views. Eliminate unnecessary background drawing and overdraw by setting backgrounds exclusively on the outermost container view. Avoid using transparent views where possible, which significantly reduces the graphical processing unit workload during rendering. The binding method, whether on bind view holder on Android or cell for row at on iOS, executes frequently during rapid scrolling and must complete its execution extremely quickly. Pre-calculate all necessary display values, such as formatted dates, localized strings, or derived properties, within the data model layer before the data reaches the adapter. Strictly avoid performing expensive input-output operations, complex string formatting, or database lookups directly inside the binding method implementation. For image loading tasks, utilize asynchronous libraries like Glide or Coil on Android, or Kingfisher or SD Web Image on iOS. These libraries handle caching and background loading automatically. This ensures the main thread is never blocked waiting for image data retrieval or decoding, maintaining the critical 16.67 millisecond frame budget. Never invoke notify data set changed for list updates, as this command forces the complete rebinding of every visible item, inevitably causing noticeable jank. Developers must implement DiffUtil to calculate the minimal set of changes between the old and the new data lists asynchronously on a background thread. Override the getChange payload method within the DiffUtil callback implementation to enable partial binding updates. When only a small property changes, such as a toggle state or a counter value, the payload mechanism allows the adapter to update only the specific view element. This means updating just an icon or a text color without requiring the rebinding of the entire view holder structure. Utilizing payloads significantly reduces central processing unit usage during frequent data updates, preserving smooth scrolling performance. Implement the UITableView data source prefetching protocol to receive advance notifications regarding index paths that are about to scroll into the visible area. This mechanism allows developers to initiate necessary data fetching or complex processing for upcoming cells on a background queue. Ensuring the required data is fully prepared when the cell for row at method is finally called eliminates main thread delays. Adopt UICollectionView Diffable Data Source or UITableView Diffable Data Source for managing the list state effectively. Diffable data sources automatically handle all insertion, deletion, and movement animations by comparing data snapshots. This eliminates the error-prone manual management of index paths and ensures data consistency. Using diffable sources minimizes performance impact during list modifications, providing a robust and efficient solution for high-volume data lists. Performance optimization requires precise, quantitative measurement of rendering time. On Android, utilize the Profile Graphical Processing Unit rendering tool to visualize frame rendering durations. Any bar exceeding the green 16.67 millisecond line indicates a frame drop, known as jank. Use Systrace or Prefetching to analyze detailed thread activity and identify exactly which method calls are consuming excessive time on the main thread during scrolling operations. On iOS, the instrument suite is mandatory, specifically the time profiler and core animation tools. The core animation instrument reveals critical issues like excessive blending caused by transparency and costly off-screen rendering operations, which are major contributors to graphical processing. Unit bottlenecks. Focus all debugging efforts on optimizing the layout and draw phases identified directly by these specialized profiling tools.